Purple West, homeschooling and digital coaching.
Students, now we will discuss about the batteries.
Batteries are a triumph of science. They allow smartphones and other technologies to exist without anchoring us to an infernal tangle of power cables. Yet even the best batteries will diminish daily, slowly losing capacity until they finally die. So why does this happen? And how do our batteries even store so much charge in the first place? It all started in the 1780s with two Italian scientists, Luigi Galvani and Alessandro Volta, and a frog. Legend has it that as Galvani was studying a frog's leg, he brushed a metal instrument up against one of its nerves, making the leg muscles jerk. Galvani called this animal electricity, believing that a type of electricity was stored in the very stuff of life. But Volta disagreed, arguing that it was the metal itself that made the leg twitch. The debate was eventually settled with Volta's groundbreaking experiment. He tested his idea with a stack of alternating layers of zinc and copper separated by paper or cloth soaked in a saltwater solution. What happened in Volta's cell is something chemists now call oxidation and reduction. The zinc oxidizes, which means it loses electrons, which are in turn gained by the ions in the water in a process called reduction, producing hydrogen gas. Volta would have been shocked to learn that last bit. He thought the reaction was happening in the copper, rather than the solution. Nonetheless, we honor Volta's discovery today by naming our standard unit of electric potential the volt. This oxidation-reduction cycle creates a flow of electrons between two substances, and if you hook a light bulb or vacuum cleaner up between the two, you'll give it power. Since the 1700s, scientists have improved on Volta's design. They've replaced the chemical solution with dry cells filled with chemical paste. But the principle is the same. A metal oxidizes, sending electrons to do some work before they are regained by a substance being reduced. But any battery has a finite supply of metal, and once most of it has oxidized, the battery dies. So rechargeable batteries give us a temporary solution to this problem by making the oxidation-reduction process reversible. Electrons can flow back in the opposite direction with the application of electricity. Plugging in a charger draws the electricity from a wall outlet that drives the reaction to regenerate the metal, making more electrons available for oxidation the next time you need them. But even rechargeable batteries don't last forever. Over time, the repetition of this process causes imperfections and irregularities in the metal's surface that prevent it from oxidizing properly. The electrons are no longer available to flow through a circuit, and the battery dies. Some everyday rechargeable batteries will die after only hundreds of discharge-recharge cycles, while newer advanced batteries can survive and function for thousands.
Now, as you know that the batteries are very important. If you just see that any electronic devices, whatever is present at your home, say the remote of the TV or the battery which is present in the wall clock, they also contains the battery. So simply speaking, the battery, it is a device where it is an electrochemical cell, I will say. Electrochemical cell means you know now very well that the chemical energy gets converted to the electrical energy. So the main thing you have to remember that here a spontaneous reaction is taking place. Here the spontaneous reaction is taking place and chemical energy is getting converted to the electrical energy. Okay, so that is a battery. Now batteries are of various types, that is primary battery, secondary battery and the fuel cell. Okay, now in many of the cases you know that the batteries consist of group of two or more electronic cells connected together electrically in series. Okay, that is also there in many of the cases. If you will open the remote, then you will see that remote of the television, which is nowadays the most important thing, I will say. So if you will open, you will see that there are 2-3 batteries which are connected with one another. So in many of the devices you need only one battery. In some of the devices we need few more batteries. Okay, so there are 3 types. One by one we will discuss about these. So first of all, we will discuss about the primary batteries. Okay, now primary batteries, you have to remember that primary batteries, again I am reminding you that it is an electrochemical cell. That means electrical energy is getting chemical energy, a spontaneous chemical reaction is taking place, and that chemical energy is getting converted up into the electrical energy. Okay, now primary batteries or primary cell is that which is used only for once. You can use it only for once, and then they get discharged, then you have to discard it. That doesn't mean that today you have installed one battery in your some device, and today only you have to throw it. No, it is not like that. It is like that once you have used it, have a particular lifetime. After that particular lifetime, that depends upon the use, that how much you are using it and what is the volt of that. So based upon that, it have a lifetime. For example, if you take a remote battery, okay, so it can work for about 3-4 months. Sometime it works only for 2-3 months. So it depends that how much voltage it is giving to you and how much you are using it. So they are designed in such a way that they can be used once, and then they have to be discarded. They can't be recharged. You will not be able to recharge the primary cell. So primary cell are non rechargeable, that you have to remember. They are unrechargeable. There is no reversible reaction. So these are what, here there is a spontaneous chemical reaction is taking place, which is generating electrical energy, and it is like that. Once it is used, once it is completed its life cycle, you will not be able to recharge it. You have to throw it away. Now secondary cells are those which you can recharge. Okay, which you can recharge again and again. Actually what is happening, these are the cell, these are also electrochemical cell only. That means electrical energy is getting converted up into the electrical energy. You can see this is anode, this is cathode, as we have discussed earlier. Okay, they are separated by the membrane, or you have seen that it is separated by the salt bridge. Similarly here it is separated by the membrane or semi permeable membrane type, so that the electrons and ions can move through it. Okay, so these secondary cells, they are rechargeable. You can recharge it because they have a reversible reaction happening in them. When you are using it, then what is happening, the chemical reaction is taking place and it is generating electrical energy. When it is discharged, then you have to supply electrical energy into this, and then the electrical energy will result into the conversion of the chemical energy. Okay, then the chemical reaction will take place normally. So this is happening in the most useful thing, which without which you can't survive nowadays. That is your remote. Okay, that is your, for example, that is your, some of the remotes are rechargeable, some of the these mobiles. Okay, mobiles mainly contain these rechargeable battery. Okay, now we will discuss one by one. For example, I am talking about the Lagrange cell. Okay, Lagrange acidic dry cell. It is a primary cell. Okay, now understand very carefully. Now this is the device, this is the cell, and this contains covering. This covering is the anode. You have seen the batteries, so they have a covering. Okay, these coverings are what you will see, some of them are the red in color, some of them are black in color. So this covering, the container is also an electrode, and inside the center also there is an electrode. Now this container is an electrode, which is the anode. Okay, what is the name of this container? That is, it is anode and it is made up of zinc. Okay, at the center you will see that there is a rod like structure. This is the graphite rod and this is the cathode. Okay, so container itself is zinc, outer covering is not. Outer covering is painted. Some of the batteries you will see that they are painted red or black or yellow in color. So they have painted it actually to prevent oxidation or exposure to the atmosphere, and sometimes they write the name of the company is also okay. So the inside container, the inside covering, you will see that is the zinc container, that is anode, and this rod is the cathode, and there is a terminal also. This top terminal, it is a positive terminal, the lower one, it is a negative terminal. Now there is a mixture present inside it, that is the mainly the MnO2 and NH4Cl. Okay, MnO2 and NH4Cl is present, and NH4Cl is mainly acting as an electrolyte. Okay, so what are the electrolytes? And ZnCl2 and NH4Cl, these are the two electrolytes. Now you have to remember what, that anode is made up of zinc or manganese. So in anode I have explained you that the oxidation takes place. So oxidation means, again I am repeating, that is the loss of electron. So Zn is going to lose electron, so it will become Zn2 plus and 2 electron, you can see. Now cathode is the graphite rod which is getting oxidized. Okay, which will, here the oxidation will take the cathode, where the reduction will take place. So what is the thing? MnO2 is reduced. Okay, again I am repeating, anode is the Zn where the oxidation is taking place, cathode is the electrode where the reduction takes place. Okay, so what is getting reduced? MnO2 is getting reduced. So MnO2 plus NH4 plus came from where? From NH4Cl. Okay, so from this the NH4 plus is there. So NH4 plus 2H2 plus 2E minus, that is the electrons which is liberated here in the anode, it is coming to the cathode. Okay, so what you are getting, just see NH4 plus, because NH4Cl is an electrolyte. As soon as it is in the solution, it will dissociate into NH4 plus ion and Cl minus ion. Okay, so that NH4 is taking part in the reaction here, plus 2H2O plus 2 electrons from here. So what you are getting? NH4OH, and Mn is given out. So Mn whole to OH, that you are getting. Now the cell voltage here, what is the voltage of the cell? That is 1.5 volt. 1.5 volt, and it is non-rechargeable. It is expensive. Okay, it is non-rechargeable. So this is about the Lagrange cell. So I am again repeating, Lagrange cell is acidic tricell. Now one drawback of this Lagrange cell is that here NH4Cl is there, so you can see after some time the ammonia will be released here. That ammonia reacts with Zn also, and it forms a complex with the Zn. So that's why they don't burst and open, because if the gas is produced from this here reaction here, that ammonia is released, then it should burst and open. So but that is not happening, because that ammonia which is produced here, it reacts with the zinc. Okay, and it form a complex, and so it is not bursting and opening. But you will see that certain amount of discharge, when you are going to keep this cell for a long time, you will see that something is coming out from here, some white discharge or some other brown color discharge is taking place. This is actually what is that salt, that complex which is formed by the ammonia and Zn, that is start coming out when you have kept this cell after the discharge. Also when it is getting discharged and you have kept it for some time, so you will see this type of the things coming out. Okay, so we have discussed what? We have discussed about this is the primary cell. Again I will make you remind that primary cell is an electrochemical cell only, which is non-rechargeable, and in this spontaneous reaction is taking place, and it is not a reversible cell. It is not a reversible cell. Okay, Now, this is again, I'm talking about the dry cell or the Lagrange cell only. You just see the proper reaction is there, that how the ammonia is also produced here. And that ammonia, as I have told you, this ammonia is reacting with the Zn2 plus, and it is forming a complex of ZnNH3 whole 2, okay, and Cl2. So this was invented in 1860s. The common dry cell or the Lagrange cell has been familiar a household item. An active zinc anode in the form of a can house a mixture of MnO2. That means inside this there is a mixture of MnO2, and an acidic electrolytic paste consists of NH4Cl, that is ammonium chloride, zinc chloride, and H2O, and starch powders. Graphite improves conductivity. The inactive cathode is the graphite rod. Here the graphite rod is not taking part in the reaction, although it is serving as a cathode here, but who is reacting here? This is MnO2 is reacting there. MnO2 is reacting there. Now just see the anodic reaction, which I have already discussed, but you just see again to revise it, that the zinc solid is getting converted to Zn2 plus and 2E minus. So Zn is getting oxidized, and in the cathode half cell is a complex, and even today is still being studied. MnO2 is reduced to Mn2O3 here. Here, although the zinc, I will show you again, the graphite rod is there, but it is not taking part in the reaction. It is cathode, but which is taking part in the reaction? MnO2 is taking part in the reaction. You can see MnO2 is reacting with NH4 plus, which is the electrolyte. So it is forming Mn2O3 plus 2 NH3 and H2O. Okay, now NH3 which is produced. Now this is a gaseous component. So actually what should happen when there is a gas in a closed container? It should burst and open and break, but it is not happening. Why it is not happening? Because this ammonia is reacting with Zn2 plus and chlorine which is released, and it is resulting in the formation of this complex. Okay, as I have told you that if you are going to store this dry cell for a long time, after when it is discharged also, then you will see that certain brown thing is coming from the knob here, this place tip. It is something comes out. So that is what? That is this NH4 Zn NH3 whole 2. Actually this electrode push it out, this thing, and you will be able to see it here. So this is the overall reaction, that is cathode anode plus the cathode. Okay, and E cell is this one. So what is the use? Common household item such as portable radios, toys, flashlights. Okay, and this is the main uses. Now what is the advantage of that? It is not so expensive, safe, and available in many size. Now disadvantage is that at high current drain, ammonia builds up, causing a drop in the voltage. Okay, so when you are using it for a long time, so ammonia will be produced, that will result in the dropping of the voltage, and that will again react with the zinc, and as you have seen that it will result in the formation of this. And as is this NH4Cl is slightly acidic in the character, and hence it start degrading this electron. It will start degrading the electron. Now I am going to the next cell, that is the mercury cell. Mercury cell is also known as button cell. You can see the shape also, it is like a button. The most, yes, you are thinking the correct thing. It is mainly used in the watch which you always wear. So this is the main useful in the watches. So you can see that the container here, again the container itself is going to act as anode. Okay, the container itself is acting as an anode which is made up of zinc, and cathode is present inside here. The cathode is present inside here, which is the paste of silver, mercuric oxide, HgO. It is a paste of HgO which is acting as an cathode. Okay, This is the gasket. It is a solid covering you can see, and this is a cell can which is present outside. This is anode, the tip which you can see, that is an anodic cap. Okay, the electrolyte is a paste of KOH and ZNO here. Now the volt you can see, it is 1.34 volt. It is slightly less as compared to here. You can see here in the Lagrange cell the volt is the 1.5 volt, and here in the case of the Mercury cell it is 1.35 volt. Okay, now just see the exact diagram how it looks. You have seen many a times because all of us are wearing it on in our watch. So you can see this is the sealed container. The top is the anode. Okay, electrolytic solution contain KOH and the paste of ZNOH whole 2, and there is also HGO present inside it, which acts as a cathode. Okay, now I am going to the secondary cell. Now secondary cell are most important nowadays, I will say, because they are rechargeable. We need it deadly. Now whenever the light is not there, you know that we all use inverters. So inverters are basically what? They are secondary cell. Or if I talk about the mobiles, okay, they are secondary cell. They contain the secondary cell inside them. Even the laptop which I am using right now, it also contains the secondary cell because it is rechargeable. We are using continuously. So what is this? They are the rechargeable batteries. So here the reaction can be readily reversed. Okay, so whatever reaction is taking place, it can be reversed. Similar to primary cell, except redox reaction can be reversed. In the primary cell, you have seen that it is not possible to reverse the reaction. But here in this case, we can reverse the reaction. Now these are rechargeable, that the electrodes undergo the opposite process than discharging. Cathode is oxidized and produce electrons. Electrons are absorbed by anode. So this is happening when you are recharging it. So I can say that when you are recharging it, it will get converted to an electrolytic cell. And when it is in use, then it will remain as an electrochemical cell. When we are using it as an inverter, then it is an electrochemical cell. That means chemical energy is getting converted to electrical energy. When we are recharging it, we have attached it to the external source, then it is acting as an electrolytic cell. Now one by one I will discuss about that. So two are there in your syllabus, that is the lead storage battery, and second is the nickel cadmium storage cell. Now just see lead storage battery. You can see the diagram. It is consist of the lead electrodes. Okay, and there are also porous lead electrodes. Alternate you can see from the diagram. It is visible. These are the solid lead electrodes, and these are the porous lead electrodes which are filled with what? Lead oxides. Okay, so one is lead and other is the, we say that it is the spongy lead, or it is filled with the lead or dioxide, and the electrolyte which is present here is dilute H2SO4. It is very less, that is 38% by mass. The H2SO4 is present in this. Now let us see, and you can see that there are many these cathodes or anodes are arranged alternately. You can see these are the anodes, light blue, which are connected here, and these are the cathodes, okay, the dark blue here in this direction. Now understand this clearly. It normally consists of 6 voltaic cells connected in a series. In each cell, a node is made up of spongy lead, and cathode is a grid of lead packed with lead dioxide. So here this is spongy lead, okay, and this is it is a grid means a porous lead is being taken which is filled with the lead dioxide. Electrolyte which is taken here is H2SO4 solution. Now sulfuric acid is consumed in the reaction. during the discharge of the battery. As a result, the density of acid falls. When the density of the acid falls below this, that is 1.20 gram centimeter cube, the battery needs to be recharged again. Okay, so at anode, what is taking place? This lead, solid lead, is reacting, because I have told you right now that the anodes are made up of spongy lead. Okay, so this spongy lead is reacting with the SO4 minus. Okay, SO4 minus is coming from where? Because we have taken H2SO4 here. So it is releasing, it get dissociated into H plus ion and SO4 minus ion. So that SO4 minus ion is consumed here. Now it is forming PbSO4 and 2 electrons. Now at an cathode is what is taking place. As you can see that the cathode are the porous lead filled with the PbO2. Now this PbO2, which is in the solid state, reacts with SO4 minus and the hydrogen also, because I told you that H2SO4 is dissociated into H plus and SO4 minus ion. So that HO4, that H plus ion is also getting taken away here, and the electrons which are released, that is also taken away. So here you are getting PbSO4 plus this water. Now for overall reaction, we will add this to, okay, add the reactant, and you will add the product side also. So this is the overall reaction. Now when we are reversing this, then you have to reverse the reaction. Means your reactant, when we are reversing it, means when we are recharging it, I will say. So when we are recharging it, then what you will do, you will take PbSO4 solid plus H2O, that you will write in the reactant side, and the product side will have Pb solid plus PbO2 solid plus H2SO4. So this is going to be your reaction for recharging. Now this is, as I have told you, the inverters are the best example for the lead storage battery. But one of the disadvantage of the lead storage battery is that they are bulky in the size. They are bulky in the size, so they have a heavy load also, because this lead grids, they are, and the H2SO4 solution, so all this, they become actually heavy, so it is not easy to carry. So if you want to shift it from one place to another place, it becomes slightly difficult. Okay, so that is only the one of the drawback of this lead storage batteries. Okay, but as compared to the nickel cadmium battery, I will say these are less expensive. Nickel cadmium battery is slightly more expensive. Okay, now there, see here, what is the thing here? They are very small in the size, they are compact, they are expensive, but they are compact also. So you can see that in this the cell anode is made up of the cadmium, and the cathode is comprised of the metal grate containing nickel oxide, and the electrolyte is KOH solution. The cell has a voltage of about 1.4 volt. Now just see the nickel cadmium battery, the advantages. This is actually reliable. They operate in a range of the temperature, tolerate, it can be used for a long time. Now disadvantage is that this is 3-4 times more expensive than lead acid. Its materials are toxic, and recycling infrastructure for large nickel cadmium battery is also limited. Now these are the things, that what are the advantages and disadvantages, because comparison is there. You can see lead acid battery, it is inexpensive. Main advantage is that it is inexpensive, it is simple to make, well understood, dependable, low maintenance. This doesn't need a lot of maintenance in this. Okay, now here the disadvantage is that this is low energy density, environment unfriendly. Okay, that it releases a certain amount of the lead in the atmosphere, can't be stored in the discharged condition. It is very difficult to store it, because you can see that it is a bulky box, and these are small cells. The nickel cadmium batteries, you can see, they are the small cells. They are fastly recharged, they have a long life, high number of the charge discharge cycles they are having. They don't have high number of the charge and the discharge, this lead acid battery. Now the disadvantage is that low energy density, they are environment unfriendly. They are also environment unfriendly, significant, because any chemical you are using, ultimately certain amount is coming to the atmosphere. So we can't say purely that they are environment friendly. Now the next is the fuel cell, which is very important. This is also known as hydrogen oxygen cell. Okay, this is again a very important, I will say, because the one of the most important use is that its outcome is what? H2O. Okay, here you will get the product that is water, and water we can consume because it will, you will get a pure form of water here, so that we can consume also. So generally it is used by the astronauts. They implant this cell there, and because that is used for generating energy also, and as well as the byproduct they can drink. So this produce electricity through a chemical reaction, but without combustion. This is the most important thing. Convert hydrogen and oxygen into water. So hydrogen and oxygen into water operate much like a battery, except they don't require electrical recharging, can regenerate power almost indefinitely as long as they have a fuel cell to be used. Now working, just you have to understand, just you can see that this is a compact cell. Okay, now from one side the hydrogen gas is passed, from the other side the oxygen gas is passed, and you can see that it is connected with one another. Okay, and here the electrical energy is discharged. So hydrogen atom enters the fuel cell at the anode, where a platinum catalyst causes the hydrogen to split into positively charged ions. Okay, that means H plus ions and negatively charged electrons. Understand this very carefully. There are two electrodes. These are the platinum electrodes present. Now hydrogen gas is passed from the anode side. Now as soon as the hydrogen gas will come here, that hydrogen gas will dissociate and liberate H plus ion. Okay, and H plus ion and electrons, that who is doing this platinum, which is acting as an electrode as well as a catalyst here. Okay, now positively charged hydrogen ion which is produced here, it will react with the OH minus ion formed in the water, because it is here the water is also present. So now this water contains OH minus ion, so that H plus will react with the OH minus ion, and it will result in the formation of water. Now negatively charged electrons can flow through the electrolyte and reach the positively, here it is reaching from, it is traveling, the electrons are traveling from here and it is going toward the cathode. It goes toward the cathode, it moves from here and then it goes toward the cathode. Okay, and the circuit is getting completed. Again understand, the hydrogen we are passing from here, anode is made up of platinum. Platinum is also acting as a catalyst here, so it is helping to break this hydrogen to H plus ion and electrons. Now that H plus ion will react with the OH minus ion, it will form water. Now electron will move from this anode to the cathode. Okay, it is completing the circuit. Now oxygen enters the fuel cell toward the cathode, and this oxygen picks up the electron which is coming here. Okay, and traveling to the electrolyte, it is going to the electrolyte. Now the anode, which where it combines with the hydrogen atom. Okay, it combines with the hydrogen atom. Now oxygen will take the electrons, the oxygen will take the electron, and it will result in the formation of the water molecule. Now there is many advantages of the hydrogen, this hydrogen oxygen fuel. That the main thing is that unlike petrol and the diesel, the hydrogen does not generate carbon dioxide when burnt. Hydrogen fuel cells are very efficient. However, there are also certain disadvantages. Few filling stations sell hydrogen, only few filling stations are there. There is getting the hydrogen becomes difficult. That is the thing. Now hydrogen must be compressed and liquefied and then stored in a container. Okay, atmospheric pollution may be generated during the production of the hydrogen. The mainly the product here is water, which is not causing any harm, which is not causing generating any impurity. But main thing is that when we want hydrogen, that hydrogen, getting hydrogen from the atmosphere may cause certain type of the pollution. Okay, now what are the benefits of this? What are the benefits of the hydrogen as a fuel? Now, hydrogen exists in an unlimited supply. Hydrogen is renewable. Now, hydrogen is clean burning. Water is main byproduct here. No carbon dioxide is released in the atmosphere. That is the main thing. It is not causing any pollution. Now, hydrogen weighs less and generates more power than hydrocarbon fuel. Okay, now hydrogen burns faster and at a lower temperature than conventional gasoline. So this is the thing. Now I am going to the corrosion. Okay, next topic is the corrosion. Now just see, this is the, up to this the batteries and the cells are over. We have discussed two types of the batteries, that is the primary battery and the secondary battery. Primary batteries are what? Yes, you are very correct that they are non-rechargeable, and secondary batteries are rechargeable. Then we had a talk about hydrogen oxygen fuel cell. Now we came to know that they are very much beneficial. Okay, now we are going to the corrosion. Okay, now if there is, just imagine there is a iron block, okay, which is present just outside your house. Okay, now that iron block, I will say that it is an electrochemical cell. Why? Because it is exposed, this iron block is exposed to the atmosphere, it is exposed to the rainfall, it is exposed to the moisture, humidity, sunlight, everything. Now, it is acting as a electrochemical cell. How? One portion of it starts acting as an anode and other portion of it start acting as a cathode. So as you know that anodes, they have a tendency to lose electron. That means oxidation takes place in anode. So what is happening? Fe is getting converted to Fe2 plus and releasing electron. Fe2 plus is getting converted to Fe3 plus and releasing electron. Now these electrons are going to the cathode. Okay, now cathode, what is happening? These electrons are there as it is exposed to the atmosphere, so oxygen is there, rainfall is taking place, so water is also coming in contact with this iron slab. So oxygen from the atmosphere, the water from the rainfall, or the moisture, the humidity, even the rainfall is not taking place. Okay, it is a sunny day, just imagine. But what is the thing? The oxygen is there in the atmosphere, which you can't stop, and the moisture is also present in the atmosphere. So H2O in the form of the moisture and the electron. So it will result in the formation of 4OH minus. Okay. Now what is happening? This Fe is then reacting, and the formula of the rust, you can see this. Okay, so it is, and what rust is a weakening of iron due to oxidation of its atom, otherwise known as electrochemical corrosion. Now let us see what is happening. Electrochemical or redox reaction are tremendously damaging to modern society because there is rusting of car is also taking place. Okay, the cars, you might have seen that if you have purchased a new car, after 1 month or 2 months, you will see that it is losing its luster. Why this is happening? This is happening because of the rusting of the car. Okay, so what is happening here? The anode, you can see the loss of electron is taking place. Cathode, atmospheric oxygen, moisture or water content of the atmosphere reacting with these electron and generating OH minus. Now this iron is reacting with the O2 and H2. Overall reaction is this then. Okay, now this is resulting, the net reaction is happening this. So now we can minimize it by sacrification, cathodic protection, galvanization means coating with something, coating with the for example, we are coating it with the zinc. So what will happen? The zinc will react, but nothing will happen to the iron. Okay, we can just paint the iron. You might have seen that the windows and the doors, they are painted. They are also made up of iron, but they are painted. Why? Because to prevent the corrosion. Okay, so there are various processes of preventing corrosion. This is all with the electrochemistry.
I hope this chapter is clear to you. Before moving forward, you should go through the reading material, revise the chapter and make your own handwritten notes. That is very important. If you have any doubt, please follow the instructions given below or contact Purple West Help Desk to schedule a live session with me. Coming up next is your test. I wish you all the best. Thank you.